One of the most important decisions in training deep learning models is setting the learning rate. But here's the problem: single fixed learning rate does not always work. So if the learning rate is high, you will, let's say, overshot. If it's low, you will crawl, and you might not, let's say, getting the minimum, the optimal minimum. And that's where the learning rate schedules come in. And they dynamically adjust the learning rate during the training. So for fast convergence, better generalization, and also smart optimization. So you will start with a specific value for the learning rate, but after specific, let's say, interval, or let's say epochs, the learning rate will be updated. And we have several, let's see, schedulers. So the one here, the first one is step decay. Here's the learning rate drops by a fixed factor at set, let's say, of interval. It's simple, effective, and great for a large data set and simpler model. And the second one is exponential decay. The learning rate decreases continuously in an exponential curve. So it's like perfect for consistent, smooth, and convergence. And the cosine annealing, this one is follows, let's say, cosine wave. Is gradually reducing the learning rate and sometimes resetting it. So it's especially powerful for deep learning, for deep networks and fine tuning. And the cyclic learning rate, the learning rate here is goes up and down periodically. Why? Because they because those ups helps the model to escape local minima and find the better, let's say, global solutions. So you can see here, this is the benefits. The benefits of this scheduler is huge indeed. Faster, let's say, convergence, better fine tuning, and also escaping saddle buoyant. And the last one is, let's see, improving the generalization. So the key inside learning rate schedules give you the best of both worlds. Let's see, high learning rate to speed up the training and low learning rate to find the tune performance. So by adapting the learning rate at the right time, they help you, let's say, they help the models convergence faster and smarter. And also remember, the it's not just about choosing, let's say, learning rate. It's also about to find the right schedule. And as you can see here, let me just move this. As you can see here, for this step decay, it's better for large data set, simpler model, consistent convergence need, deep networks, fine tuning, and skipping local minima. And you can see also this is the complexity. And that's it for today. Thanks for watching, and see you next time.